we need to find the value of the given definite integral. So here we have a vector valued function e raised to the power of t I cap plus e raised to the power of negative 2t j cap plus t k cap, and we have to integrate it with respect to t. So let's begin. So first what we'll do, we will separate each of the individual components. So that means we'll integrate the x, y and z components separately. So that will be 0 to 1 integration of e raised to the power of t dt. So this is the x component, so we'll multiply it with I cap, plus we'll take the integration of the y component, so that will be integration 0 to 1 e raised to the power of negative 2t dt. So this is the y component, where we'll multiply it with j cap, plus the third term. So the third term will be integration 0 to 1 of t dt, and this is going to be a z component, so we'll multiply it to k cap. Fine. So that means integration of the exponential function gives the exponential function e raised to the power of t with the limits running from 0 to 1, and this will be x component, so we'll multiply with I cap, plus integration of e raised to the power of negative 2t, so that will be negative half e raised to the power of negative 2t with the limits going from 0 to 1, so this will be j cap, plus integration of t dt, so that's half t squared with limits going from 0 to 1, and this is our z component, so we'll multiply it to k cap. So let's plug in the limiting value. So we have e raised to the power of 1 minus e raised to the power of 0 I cap, plus let's take the negative outside, so we have negative half multiplied to e raised to the power of negative 2 minus e raised to the power of 0, so that's j cap, plus half t squared, so that will be 1 squared minus 0 multiplied to k cap. So that's equals to e minus 1 I cap minus half e raised to the power of negative 2 minus 1 j cap plus half k cap. So this is the integration of the given vector valued function with limiting values going from 0 to 1.